Yeah, hi. In this session, we are continuing with the Matplotlib, the Python visualization library. Okay, to start with, first we import the libraries NumPy, Pandas, and Matplotlib. So the version I'm using is 3.1.3, the Matplotlib version. Okay, the topic we start with is the backends topic. So, what is a backend? So basically, Matplotlib has multiple backends that actually help Matplotlib's uh, in-memory representation of plot to get converted into the output that appears before us. So by default, there is a backend inline that gets assigned when we are using, let's say, Jupyter Notebook. This is what I'm using right now. We can also change the backend if you want to. We can the way to change the backend is matplotlib.use and name of the backend. To find out which backend is currently being used, we can say matplotlib dot get underscore backend. So if we set it as nbag, then it will return the backend as nbag. Otherwise, the default is inline in Jupyter Notebook. Whenever we execute this line percentage matplotlib inline, so basically what this IPython magic command does, it actually sets the backend as inline, and at the same time it also executes a function plt dot I on. What it means, it will set the plots as uh, in the interactive format. What it means, as soon as we execute the command, immediately the plots will be displayed before us in this Jupyter notebook. Uh, the opposite of this function is plt.ioff, which means the plots will not be displayed until we explicitly call plt.show to display the plot. One thing to mention is whenever we are setting a backend, we have to set the backend first using matplotlib.use command, and after that only we should do import matplotlib.pyplot as plt. Okay. So to start with, we are just reading data from a file called as players.csv. This contains the number of centuries scored by different batsmen against in their career, and this is what the data looks like. It has name of the player, country the player belongs to, matches played, batting average, centuries scored, highest score, runs total runs in the test career, and the number of ducks is by that player. So let's say our requirement is to plot the number of centuries scored by each batsman, and we want to specifically highlight one that batsman who has scored the maximum number of centuries by coloring the bar corresponding to that player name in a different way, in a different color. So this is the output that we want to achieve. So we have the players and the number of centuries scored by them. We see that Sachin has scored the highest number of test centuries, so we want his the bar corresponding to his name should appear differently compared to rest of the others. So how do we achieve this? We are just saying ax. First, we have to say plt dot subplots and store the output in figure and axes. Now we are saying ax, which is axes dot b bar h represents the horizontal bar. Variables which we want to plot, name of the player and the centuries, and this is the data coming from the player's data frame. We will set the X label in the title. Now this is the code that we are using. So one thing to note here is whatever so whenever we are calling a function to plot any to do any plotting, it actually returns an object. So here we are, when we are calling ex.bar h, it will return an object which is actually we are storing in this bars. So now we can use this particular object to access the individual bar. So now we are looping through uh, this bars, and the centuries is scored by the player. Wherever the century is the maximum, we are setting the bar with a different color. So what we're doing here, we are just using this zip function to loop through this bars object as well as with the player centuries, and we are comparing wherever the century is the maximum for that particular bar, set the edge color to dark red and the face color to salmon and the line width to 3. So it means that a specific bar will get different edge color, face color and line width compared to the rest of the bars. So this is a nice way to actually highlight specific bar with a different color when compared with the rest of the bars. The next thing we are going to cover is a stack bar plot. So stack bar plot means we have bars on top of each other. So let me quickly show the output. Let's say we have sales data of the car, that is the number of units of two models of cars sold in different quarters, and we want to compare that between those two models along the different quarters. So what we are using here is the stack bar plot. That is, we are creating one bar on top of the other. So that is why it is called as a stack bar plot. So this bar represents for model, blue color represents model A, and this yellow color represents model B, and we are displaying it for different quarters. So let's see how we achieve this. So we have this quarters as a list, Q1, Q2, Q3, Q4, and the model A and model B. These lists represent the number of units sold in that respective quarters. So to start with plt.subplots, capturing it in figure and axes. Now, first we want to do the normal bar plot by saying ax.bar. On the x-axis is the quarters, and the bar should be of length represented by the numbers given in the model A, and we set the label as A. Now we want to plot the next bars, that is corresponding to the model B, such that those bars should begin on top of the bars which were represented by model A. So, so, our- so the additional parameter that we have to specify while using ax.bar function is this bottom. So what we are saying is quarters is on the x-axis, Q1, Q2, Q3, Q4. Model B is the length of the bar of the model B. Now it should begin, so the bottom of this bar should be where the model A bar actually ended. So in this way we will stack one bar on top of the other, and then we are just simply setting the label y-axis title and the legend, and we are just displaying it. So this is a very nice way to actually do the comparison between the two different models along the quarters Q1, Q2, Q3, Q4. In the previous one, the color of the bars was coming by default. We have an option where we can set the color of the bar from the color maps. So basically, Matplotlib has a number of built-in color maps, and we can pick any one of those color maps, and we can set the colors from that. So how do we do this? We just simply say from Matplotlib import CM, which represents color map. Now to get the colors for a given color map, which is pre-default in the which are default set in the Matplotlib. So we say cm dot get underscore cmap and name of the uh, color map and how many colors you want to extract. For example, four. So this will extract four color from this dark to color map, and it will store it in this particular variable. Then this data is same quarters model A and model B. Now in this case we have a slightly different representation. What we are doing is we are displaying model A and model B like this, and then we are displaying the stack bars for different quarters. So this represents the sale of model A cars in quarter 1, quarter 2, quarter 3, quarter 4. Similarly for model B, quarter 1, 2, 3, and 4. So how do we achieve this? We have to do some data preparation to achieve this. So what I've done is I'm just using np.array. I'm creating a 2D array. The first row represents a model A, the second row represents a model B. Now, since there are two rows which are indexed as 0 and 1, so I'm creating a dictionary where 0 key represents model A and 1 key represents model B. So that will be used to display the model names in the plot. Next is I'm finding out the cumulative sum of these arrays, because as we know we will create one plot one bar on top of the other. For example, for this bar its bottom will be here, that is on top of this green color, and for this yellow color or orange color bar, its bottom should be where the previous two bars ended. So basically in a way we need the cumulative sum, so that one bar should have a bottom where which is equivalent to the cumulative sum of the previous bars. So that is why we are doing the cumulative sum along the axis 1. And then we are just inserting at the index 0 an element called an element 0, which basically means that for the very first bar its bottom should be at 0, and for the next bar its bottom should start from here, and for the next bar its bottom should start from the cumulative sum of this and this. So once the data preparation is done, we are just plotting. So first we are setting the figure size as 6,4, and then we are just going through the loops. The outer loop represents the rows that we created in the 2D array. For the row 0 and 1, accordingly we are setting the model, which is model A and model B. And then for each of the rows, we are just going through the elements of the elements of each row. So now, and then we are using the bar function to plot the bar. So one thing to note, I'm using this command twice. The reason being, for the first time I want, because the difference between these two is of only labels. Because when we are using legend, it will plot as many legends as we specify in the label. Since we want it to appear only legends Q1, Q2, Q3, Q4 to appear only once, that is uh, so that is why we have to do like this. Otherwise, what it will do, it will print these legends twice, one for this particular model A and other for similarly for model B, which we don't want. So that is why I'm using it in this way. That is, we are specifying labels only at one time, only for the first particular row, not for the other one. And this is ax dot bar. Model represents the model A or B, and then we are looping through the array. So M represents a particular row. It is 0 represents model A, row 1 represents model B, and I represents each element of that particular row. So the bottom will be the cumulative sum of the previous bars. So I'm using again the array cumulative sum that we created, and color will be picked up based on the quarter underscore colors list that we created earlier. Then we are just setting the title, Y label, and legend and displaying it. So if you see, it's a very nice comparison of between model A and model B in terms of the number of units of the cars sold in the different quarters. So this clearly tells that okay, model B sold more cars, and what was the breakdown of those units of cars sold along the different quarters. Next thing is the style. Basically, the style is used to set the different style format. It could be dark background or ggplot or seaborn dash white. So there are many styles which are available. We can select one of the styles depending upon our requirement. So based on the style that we have selected, the output that we get of the plot will totally change in terms of its look and feel. Its background color will change. Its font may change. The color which is default color used to plot that bars or the dots or circles will change. So let's take an example. So I'm setting the background as dark background. I'm reading data from one file called as Sachin. So this actually has the centuries is scored by Sachin in his career in both test and the one days against any specific country and on the ground on which date. This has both data test as well as one days. Now, if you notice in the score column, there is a asterisk appearing. So because of this, this score object is appearing as object. What we have to do, we have to remove this asterisk. Basically, this asterisk represents that he was not out in that particular innings. So we want to capture this information that he was not out in that innings in another column, which is like not out, and that should be true corresponding to the rows where asterisk is present. And once it is captured, then we want to remove this asterisk and convert this particular column into an integer so that we can use it in some arithmetic calculations. So this is what we are doing here in this data preparation work. So we are first creating a column not out. So its value will be true or false depending upon where the asterisk was present in the score column. And corresponding to that row, this particular column will get its value true or false. And then we are just replacing this asterisk with nothing so that uh, so that the column further can be set into the integer. Okay, and this is where we are setting that data type of that particular column is score into the integer. Now, if you check the data type, it is like score is integer and rest are in the form of object, and not out is in the form of the boolean, which is true or false, means he was not out in that particular innings or not. This is how our finally data frame looks like. Okay, so let's say what we want to do is we want to display the number of centuries scored by Sachin against different countries. That is, how many centuries he scored against Australia in test matches, against Australia in one day, and so on. So we want to prepare basically two charts using two different themes. So right now we have set the current theme as a dark theme, as I said there, dark background. So if you see, the output will appear something like this. So how do we first create this chart? What we are doing here is we are just doing this data prep. This is nothing but preparing the data before the final we are plotting the chart. The step one, what we're doing is we're just grouping on the basis of against and format, that is against which country and in which format. We want to count the number of centuries scored by Sachin. So against this country and format, we are doing the grouping, selecting this column score and finding the length. The length will tell the number of centuries scored against that particular country in that particular format. So this will be having both test as well as one day's data. Now we want to separate it out into two different data frames. One is ODI centuries, other is test centuries, and we are just separating it out based on the format. ODI is format is ODI, and this is for the format is test. Now again, now in this ODI century and test century data frames, we want to set index as the name of the country, and the column will be the centuries scored against that particular country. So this is how our data frames will look like. So this is ODI century data frame. The index is the name of the country, and the column is the centuries scored against that country by Sachin. This is for ODI century data frame. Similarly, we will have data for test century data frame. So let's begin with, we'll have now we want to plot the ODI centuries. First, again, plt.subplots, we are capturing figure and axis. Now, what we are doing is we are just creating a array starting from 0 to the length of the countries, or the length of the index, basically, which represent the countries. Okay, and then on the then using ax dot bar, we are doing the bar plot. On the x-axis, we are using this index count 0, 1, 2, 3, and so on, and on the y-axis, which represent the centuries scored, and data is coming from ODI century. Now we are setting y label as centuries now, and x tick is the index count, which is 0, 1, 2. That is, this tick should appear like this: 0, 1, 2, 3, 4, and the labels should be based on the country name. So we are setting the tick based on the number 0, 1, 2, 3, so on, and the label of these x-axis text is based on the ODI century index. Now, because it's the name of the country, and we want to rotate it by 90 degrees so that the names do not overlap each other. So that's why we are specifying rotation as 90 degree here. And then we are simply setting the title to a specific title. Now, if you see, because the theme was differently selected, so the look and feel of the chart is completely different from what we used to get earlier. Now, if I set the theme, if I set the style of the chart to, let's say, a ggplot, now we do the same sort of plotting for the test centuries, that is number of centuries scored by such in the test career against different countries. The logic is more or less the same. It's just that the data frame is different this time. Instead of ODIs underscore cent, we are using the test underscore century. Uh, and then we are plotting it. If you see, this is name of the countries and the centuries is scored. So so because the style is different, the color used in the bars, the background, the grids, appearance, all these things have completely changed. So so how the plot will actually look like in terms of its look and feel, it's very much determined by the style that we have selected, and based on which we will get the output in the plots. So that's it for now. Thank you.